Hello. Um, Today in this video, we're gonna talk about linear versus exponential. So this is just the intro to our next unit. So if you feel like you're confused, that's okay. Please stay calm. We have a lot to go over still. So we're gonna look at, so this is like intro, linear, versus exponential. Okay, so we have a function given to us. So a function is just an equation. It's written in function notation, so that's okay, right? Not a big deal. And then we have this table over here. And so it says use the function to fill in the table below and then graph. And then we're going to answer these questions. So the first thing I'm going to do is I'm going to look at 0, actually, because 0 is the best. So 0 is -3, which is important. So when I go to graph this, right, I'm going to care about this table because it's going to give me my answers. All right, and then it's growing by 2. So if I plug in 1, that's 2, minus that is -1. If I plug in 2, 2 times 2 is 4, take away 3 is +1, I believe. 3. All right, so if I plug in -2, that's -5, and then it should be going down by 2's. That's negative. Okay, so I got the table. Now I'm going to graph it. Okay. I am going to start at my y-intercept. So here's the origin. When x is 0, I'm going to go down 3. 1, 2, 3. Big dot there. Okay. And then this is a positive line, so it's going up left to right. So at 1 here, so this is 1, I'm down at -1. And then I can see that it's growing. 3 is also 3. 1, 2, 3. All right, and then I can sort of just like sketch these in. Okay, cool. Da, 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 da. So these are in my table, but based on the pattern, right? That's true. All right, so I am going to connect these dots. So we're not in inequalities anymore, so we don't have to worry about, oh dear, like dashed versus solid, stuff like that. So this is just a regular line, just regular line. All right, so the first question is, what type of function is this and why? So function means like line or relationship. And so I know that in physics y'all talk about like inverse proportions and stuff like that. So right now we're gonna sort of stay away from that, just because it's different. But this is a linear function because I'm going to use BC because the growth is constant. The slope, right? Growth is constant. Right? So slope is 2. It increases by 2 every single time. All right, domain. This is a little bit extra, but we're still going to talk about it because it's sort of relevant here. I mean, it is. Domain is everything that x can be. It's all the possible inputs that you're allowed to have. And this is important for like the next example. So for our domain, x can be literally anything. So we write it like this. So the domain of x is -infinity to +infinity. So like our input, which is x, can be anything. Can be, I'm going to say any value, any number. Okay. So that we talk a lot about this in Algebra 3-4. So if you're like, that's confusing, we will definitely come back to it. So stick on. All right, the range. The range is y. So it's all the possible y values. So just like for domain, for a linear line like this, it's -infinity, right? So like it's going down for forever, to +infinity. For infinity, we use parentheses or soft brackets. Okay, so output which is y. Same thing, can be any value. Okay, cool. The rate of change, oh, I already said that. So the slope, growth, rate of change. All right, I'm going to do a star. So for y equals mx plus b, I have this, 2x minus 3. So my rate of change is in front of the x, which you know and remember and love. So we're going to see some different things happening on the next page. Okay, well, let's go. Okay, oops, I don't want that. Help me. So I'm going to move this up. All right, so same thing, but we have a much different, much different looking thing. So I'm going to rewrite this because you kind of can't see it the way I want. I'll do y. It's raised to the x power. So raised to the x power. Okay. So we're going to treat this like we would. This, in hindsight, would be good if you had a calculator, and now I'm realizing that this might be annoying to graph, but you know what, we're already here, so let's just persevere. Okay. So I'm going to do some work down here, so I'm going to show this. This is true, I'll come back to that. Okay, so let's practice our function notation. Equals 1/2 to the negative third power. Oh boy. Oh dear. Oh dear. Okay. We're almost not ready for this, but luckily I'm here. All right, so when you have a negative, let me just make a note over here. So let's say that you had 2 to the negative third power. It's actually this. So if I if I have this reciprocal happen, it's actually this is hard to explain when you're not with me. I miss you guys. So it's actually going to like flip, and then I'm gonna have like a nice thing happen. So this actually, and like your calculator would tell you this, by the way. So this actually, oops, my pen turned off. It's actually 8. I know. Okay. So I'm going to fill out my table. And we should notice a pattern from my table here in a second. So that's going to be true for this as well. So this is actually 4. Ooh. 2 to the third power equals 8. 2 to the second power equals 4. 2 to the first power equals 2. 2 to the 0 power equals 1. True statement. So these numbers I'm actually going to see in my table. So g to the of negative 1, 1/2 to the negative first power is actually positive 2. Okay, so I'm going to change colors for a second. So I'm going from 8 to 4, 4 to 2, 2 to 1. So if you had to guess what my next number would be, what would you think it would be? Great. I heard everything. For the record, though, I'm going to write this down. 0 is 1, and that's like a exponent law. There's a proof that goes with that. It's pretty simple, actually, so we'll talk about that later. Okay, so you said 1/2, right? And think about it. Should make a little bit of sense. So if I have 1/2 raised to the first power, it's just 1/2. Okay, I'm running out of space, but I always do. All right, so here we get to some of our more rememberable, I know that's not a word, but I made it up. Memorable, I guess, is the right one. So exponent laws, yeah? So if I have 1/2 squared, that's 1/2 times 1/2, which is 1/4. Okay, so let's again look at the pattern here. So I went from 1 to 1/2 to 1/4. So if you had to guess what that missing piece would be, you would say what number? Yeah, perfect. I'm sure you said the right thing. 1/8. Okay, so I'm going to graph this. It's going to get a little bit hard towards the old axes here, but we're fine. 2, 4, 6, 8. Yeah, because these are going to go by 1. All right, so let me actually get some red in here. So this is 2, 4, 6, 2, 4, 6. This is X, this is Y, 2, 4, 6, 8. The other thing I uploaded the template for this so you can look at it and recreate it. If you don't have graph paper, I'm sorry, that's kind of annoying. Okay, so wheat. So -3 is way over here. Wait, no. Ah bon, on peut faire ça. Let's have this be -3, and this would be +3. Okay, cool. But these are by ones, everyone. Ha ha ha. Sorry. So that's like this is -2, 4, 6. So this would be negative. Yeah, -4, 4. Okay. What was I doing? I was graphing. Okay, -3 is +8, so I'm going to put a dot there. -2 is 4. Got it. -1 is 2. Okay. 0 is 1. 1 is 1/2. 2 is 1/4. Eeks. 3 is 1/8. But it's not touching the axes, I promise you. You're going to come in with a swoop. You're like a swan gliding on water. It's magical. Wow, that was so much. Okay, so really, I would say for now, graphing this is going to be sort of like the first thing we need to do, and then we'll get more fancy from there. But we graphed it. Yikes. What type of function is this and why? Okay. It's not linear, because we just saw that. It's not quadratic. It's a good idea. I know what you're thinking. It's not. It's not right. So this is called exponential. Exponential. And what's happening is that 1, because 1, x is in the exponent. And then 2, the function, I'm going to say that, function is being cut in half each x input. Okay, right? So I cut in half. So I like sort of like divided by 2. Divided by 2. Divided by 2. So for linear, we were adding and subtracting. For here, we're going to multiply and divide. So maybe I'll write that over here. So like growth, or we call this decay, comes from, that's an F, multiplying, multiplying, and or dividing. Dividing. I don't know if that's how you spell that, and that's fine. Okay, so here is why this form even talks about domain and range. Domain, remember, is x, because it changes. Ooh, so cool. I'm going to leave it green. Okay, so x is the horizontal axis, right? So I just made it green. So here, as the function increases, right, so it's going up for forever, it's coming down for forever also. It's getting really close to this axis. It never actually gets there, which is kind of cool. So the domain is still -infinity to +infinity, right? So x can be anything. So x can be any value. Okay, the range though is special. And so here is the biggest thing, sort of like, can you tell the difference? Because the range will be altered. So the range is purple. It's your y values. Okay, so you see here that, so just like I made it green, purple, it's going up for forever. But there's a limit down here to like what I can achieve. I can't like become -4, right? So like I'm not down here. Sad. So my range, we're going to start with low to high. So it approaches 0, but it goes to positive infinity. I know. So this function, and again, you'll see this in Algebra 3-4, is never 0 or below, right? So it's never down here. It's like never. Pretty cool. All right, the rate of change. Oh dear, I kind of already talked about that with this like sad. I must want to change it to be this color real quick. Oh yes, like down here. So it's sort of what we saw in our table. So it's actually being cut in half. So the rate of change, I'm going to write it with my highlighter, is 1/2. And then I'm going to go over it with a darker blue. And we're going to use BMX, like a bike. So this is actually still going to be the letter M for us. You'll see other versions where it's ABX, but we'll use this. Okay, wow, right? It's so crazy. So we're going to review exponent laws later. For now, we're going to mostly talk about how to graph and write the rules for this. So expect that next week. I know this is a longer video. Thank you for hanging with me. And if you didn't, then you won't hear this, so you don't even know. But yeah, if you have questions, please let me know. And please also check out the Khan Academy and do the practice problems for writing and graphing. All right, see ya. Bye.